All right, hey guys, how's it going today? Um, we've been talking about energy a little bit. If you remember, there's two major kinds of energy. There's kinetic energy and there's potential energy. Energy in motion, energy not in motion, or stored energy. And when we did the energy skateboard park, we kind of threw another one at you. Total energy, by the way, total energy is made up of potential energy plus kinetic energy. And then what we did is we kind of tossed one at you. It was friction. It was thermal energy. And so now we have this thermal energy sitting here. And I thought we would spend some time on this because what we're talking about here is thermal energy. Now, the fun part about thermal energy is that we don't really have a formula for it. The question is, how do we find out if we can't calculate it like we did these two with formulas? How do we find out what thermal energy is, or the amount of thermal energy, or what's going on? And the easiest way for us to decide what thermal energy is, we grab one of these. I'll come around and show you up close. We basically grab a thermometer. And a thermometer is how we measure thermal energy, all right? This one happens to be a thermometer that's in Fahrenheit. And that's the one in our world, States and Australia that use Fahrenheit. The other one that we use is this style. It looks identical, except this one is a Celsius. So there are two types of temperatures, and that's really what we're talking about, guys, right? We're talking about thermal energy is really finding out, we measure it by taking its temperature. And there's two scales. There's Celsius, and Fahrenheit. Both these scales are based on one substance that makes it reproducible. You can't just take a thermometer and say, ooh, it's hot. You need to actually measure something. And the best way to measure something is we base both these on H2O. And for those of you who don't know what H2O is water. So both these scales are based on water freezing and water boiling. So water freezes at Fahrenheit, water freezes at 32 degrees Fahrenheit. And water boils at 212 degrees Fahrenheit. That is water freezing. I can put freeze right here. And water boil right here. All right. So you can see that there's a difference. Now in Celsius, these are hard to remember. They're kind of odd numbers. And the story about how they got these numbers is a little long. I won't share it on the video. But Celsius is a metric, which means it's based on 100s. This, not on 100. These are based on 100. So what do you expect water to freeze at? Well, that was simple. It freezes at 0 degrees. And water will boil at 100 degrees. And that's what temperature is. I'm going to kick over to a little bit different video. You're going to see some thermometers sitting on the counter. Basically, we're just going to learn how to read them today. So that's going to be the rest of this video. Give me a second to set it up. And then we should have a camera on the desktop where you can see the different thermometers and how to read them.
Okay guys, this is what a thermometer looks like. And I'll put my hands over a little bit. You can see that there are numbers up the side. These numbers are the temperature. This scale, by the way, you can see right here, it has a C on it. That means it's written in Celsius. All science is done in the Celsius language or temperatures. We don't use Fahrenheit very often for any scientific stuff. So what we're looking at then is to read one of these. You can see the scale on the side, and you can see there are numbers. I can bring it up a little closer. That there's numbers and like little hash marks that show where everything is at. Now, you can also see this thing flashing red. So inside the thermometers is a liquid that expands with temperature. And we know how much it expands by temperature because of what it looks like and experiments we've run on it. So what you do is you basically look at the top of that red line right in here, and then you just simply find the line across from it. You can see that this one's right at that little hash mark in between 20 and 30. So this temperature is actually 25 degrees Celsius. And that's how you read a thermometer. You need to make sure that you're writing down the right numbers. We can make this go up. If I hold on to this, you know, my body's warmer, you can see it start to go up. And you can see that, you know, my fingers are closer to 32, 33 degrees Celsius.
Okay, so now that we've talked about temperature a little bit, this is how we get temperature. You know, how we get, like for velocity, we get distance and time. You measure it with a meter stick to get distance, you use a stopwatch to get time. To get temperature, we use a thermometer and we simply measure it. That's the easiest way to do this. Real quick, we can talk a little thermal energy. Guys, there are 3 types of thermal energy that we're going to study here in this class. Thermal energy is movement. It is a kinetic energy, which means particles are moving. So what I want you to think about when we're doing this is particles. When particles get warm, when particles are cold, they're all hunkered together really, really tight and packed in. But as warm, move a little bit, and your space, you want this big area, and you want people away from you. So as things get warm, they tend to spread out and get bigger and want more space, and you have more energy, and that's thermal energy. Now, there are 3 ways these objects move, and we're going to talk about these 3. The first one is called conduction. The second one, convection. And the third one called gradient. Is called gradient. And these are the 3 types of thermal energies that we're going to discuss over the next 3 class periods. Conduction, convection, radiant energy. We'll run demonstrations or labs on each one of these. If you're in class, you'll probably get to do a little bit of a lab if I can get the supplies down. Otherwise, you'll get to watch me do it. For those of you at home, I will be performing the labs for each of you on each of these. So hopefully that helps. When you're ready, I don't think there's any. So good luck. Make sure you're watching your videos.